pH of a weak monobasic acid. We know that monobasic acid is nothing but basicity of the acid is equals to the 1. Then we can call it as a monobasic acid. pH of a weak monobasic acid, right? So the acid whose basicity is equals to the 1, such a acid is called as it's a monobasic acid. In this monobasic acid, let us consider the monobasic acid is HA is a 1 monobasic acid. I am taking that. Let us consider that HA is a 1 monobasic acid, weak monobasic acid. As all we have studied in the starting of this chapter is weak electrolytes are the weak acids and weak bases. These weak electrolytes definitely it attains the ionic equilibrium. It will undergo the extent of ionization is a smaller extent of ionization will be there. This smaller extent of ionization and a partial ionization takes place, and whatever the ions are formed, these ions will be some extent dissociation takes place. No, that dissociation will be so dissociated ions and undissociated molecule. There exists a equilibrium. Such a equilibrium is called as it's a ionic equilibrium. I am taking that this is in H plus ions and this is in A minus ion, right? Initially the concentration of HA is C, and what about H plus ion concentration and A minus ion concentration is 0. Even in the Ostwald dilution law we have seen this one, but anyway here we need to talk about it's a pH of a weak monobasic acid, and this will be the C alpha and this will be the C alpha. This is C into 1 minus alpha you will get, right? So this is the ionic equilibrium, means definitely you need to write down the its equilibrium constant K, the equilibrium constant for the weak acid, no, so that I can write this is a Ka. Why it is an A? A means it is representing that acid, the dissociation constant of acid. I can write this is a equilibrium constant, no, so that product of molar concentration of product of molar concentration of reactant. Here two products are there, that is in a H plus ion concentration into here it is in a A minus ion concentration, so that I can write this is in a divided by it's a HA concentration. Okay, so here I can write this is in a Ka is equals to H plus ion concentration from this equation. C alpha is there, here it is in again C alpha divided by C into 1 minus alpha is there. Alpha is already we know that in the Ostwald dilution law we have seen it is a degree of ionization, and even we have seen that factors affecting on the degree of ionization also in detail we have discussed already. But anyway here alpha is simply a degree of ionization, and Cc will get cancelled here. I can write this is in a Ka is equals to simply a C alpha square divided by here it is in a 1 minus alpha. Alpha is a weak acid, its alpha value is a very less, so that we can neglect 1 minus alpha will be equals to nearly equals to the 1, so that I can write this is in a Ka is equals to simply a C alpha square. Alright, so from this I can make the subject of the formula alpha is equals to simply Ka divided by C, square root of Ka divided by C. You can write this is a one formula, or you can use this as a formula to find out its a dissociation constant and its a degree of ionization. This is Ka is a C alpha square, alpha is a square root of Ka by C. But how we are going to find the pH of the weak monobasic acid? To find out its a pH, definitely we need that H plus ion concentration. As all we know that in this expression H plus ion concentration is equals to, we have got there is a C alpha. From this H plus ion concentration is equals to, we have got that there is a C alpha. So as all we know, basic definition for the pH is equals to minus log of this is an H plus ion concentration. Okay, this I can write this is a minus log of H plus ion concentration is a C alpha. You can write H plus ion concentration is equals to C alpha. So alpha value, if you want to substitute this one Ka by C, you can substitute here pH is equals to, simply I can write so minus log of this is an C into square root of Ka by C. So you can write like this also, and C if you will take inside of the square root, it will become as a square. That square and 1C will get cancelled, so that I can write this is in a pH is equals to minus log of so this is in a square root of particularly Ka into this is a C square divided by this is a C. 1 will get cancelled here, so that I can write this is a pH is equals to minus log of so this is a square root of Ka into this is a C. This is the formula to find out it's a pH. This is a pH of a monobasic acid. From that H plus ion concentration we can easily find out it's a particularly pH of a weak monobasic acid. This is a simple concept, nothing is there. Monobasic means basicity of the acid is equals to the 1. It's a simple derivation. Okay, next pH of a weak monoacidic base. So till now what we have discussed in the previous one, pH of a weak monobasic acid. Now we have monoacidic base. In the monoacidic base meaning is that the base whose acidity is equals to the 1. The base whose acidity is equals to 1. What is mean by acidity? Acidity is nothing but the number of replaceable hydroxyl ions present in one molecule of a base. The number of replaceable hydroxyl ions present in one molecule of a base is its acidity. Here based on that acidity, bases are classified into different types are there, but most commonly we will take 3: monoacidic base, diacidic base and triacidic base. Monoacidic base means the base whose acidity is equals to the 1, right? You can take different examples are there: NaOH, KOH, ammonium hydroxide. Some of the examples already we have I was given a list of examples, but here I am taking that general form of monoacidic base. I am taking that some general form of consider the general form of monoacidic base is here BOH. This BOH is a weak monoacidic base. Weak monoacidic base means which is a weak base only. Whenever the weak base is taken, that weak base will undergo the less extent of ionization, and there exists a it forms that there is a B plus ions, and here it is an OH minus ions are going to be formed here. So BOH, B plus and OH minus ions are going to be formed here. So consider a BOH is a general form of weak monoacidic base. It will be ionized into the B plus and OH minus. These ions, there is exist a equilibrium with the undissociated BOH molecule, so that the concentration of this BOH is a C. This is going to be 0 and this is going to be 0 at initial. At a equilibrium this is a C alpha and this is also a C alpha. This is going to be C into 1 minus alpha. Already we have seen, again C alpha we can take by subtracting that. Will get this is at equilibrium condition. At equilibrium you will get this is a BOH concentration is C into 1 minus alpha, B plus is C alpha, and even OH minus ion also C alpha, right? This is a ionic equilibrium. No, you can apply that there is a law of mass action according to that equilibrium constant definition. I am writing this is an equilibrium constant for the base, weak monoacidic base. That's the reason I can write Kb here. This Kb means which is a product of molar concentration of product of molar concentration of reactant. Here products only 2 are there. Here B plus ion concentration into, here it is an OH minus ion concentration divided by, here it is in a concentration of here it is a BOH. Okay, so B plus ion concentration into OH minus ion concentration. B plus ion concentration, how much is there in this one? There is a C alpha is there. Again, this is also a C alpha divided by C into this is a 1 minus alpha. 1 C will get cancelled. Finally, this is in a Kb is equals to, this is a C alpha square divided by 1 minus alpha. As all we know that for weak electrolytes like weak acids and weak bases, and whose percentage is alpha, degree of dissociation percentage is less than 5% is there. So generally for the weak acids and weak bases it is less than 5% only, so that here 1 minus alpha can be nearly equals to the 1, right? So that I can write here Kb is equals to, simply I can write this is a C alpha square. So for both acids and bases it's a C alpha square only, and from this I can write here alpha, you can make the subject of the formula here Kb divided by simply a concentration, right? So this is a degree of ionization for the weak monoacidic base, weak monoacidic base. But our aspect is to calculate its a pH. We got that it's a dissociation constant and a degree of ionization value, but our aspect is to find its a pH of the weak monoacidic base. So that here I can write this is in a concentration of OH minus ion is to find out, this is a base now, you will get only a OH minus ion concentration. From that you can find out the POH, from that you can find out the pH. As all we know, pH plus POH is always equals to 14, so that from that you can find its POH initially first, then you can find out its pH. Okay, so here OH minus ion concentration you are getting as this is a C alpha, and then POH as per the basic definition minus log of this is an OH minus ion concentration. Here OH minus ion concentration you have taken that minus log of, so this is in simply a C alpha. Okay, so this is simply a C alpha. Alpha value you can try it in terms of it's a Kb also. So this is a simply POH, but actually I want a pH. We know that pH plus POH both should be equals to the it's a 14. pH and POH should be equals to the 14, but I want only this pH. pH means you can write down this is a 14 minus it's a POH. Okay, so I can write here pH is equals to, this is 14 minus POH value, you can substitute this one. So minus of minus I can write minus of minus log this is C alpha. Okay, so minus of minus it will become as a plus, so 14 plus log of this is C alpha. If you want to substitute this alpha value, you can substitute even the alpha value also. This is pH is equals to, I can write this is 14 plus and log I can write this is C alpha. I can write this is directly I am writing this is Kb divided by, it's a Kb into it's a C. How we have done in the same case here also pH is equals to, simply we will get this 14 plus log of square root of Kb into C. This value definitely you will get in the negatives. Why? Because here pH value is always less than 7 or less than 14, it will be there. 14 plus it is there, that means here it may be 0 possibility this total, and it may have even some negative values also, right? So this is a concept.